All right, so I woke up this morning to a lot of questions on my feed about what's the big deal about base 12 math? Why is Dozenal math important? What is duodecimal math anyway? So I'm going to answer that question. What I've discovered in my explorations is that the actual bedrock foundation of math is in base 12. So Dozenal math is the bedrock foundation of math. There's a lot of 12ness in math that we see in base 10, but we can't really access it because we're in base 10. So right now I'm just going to show you another example of that coming into focus by looking at the special right triangle. So here I've got a version of the plastic one that you get in your geometry kit. It has the proportions of 1 and then 2 and the square root of 3. That's the lengths of this triangle. You can see it on the board here. We can look at, add a squared plus b squared, get c squared, the hypotenuse. That should be pretty familiar with. I'm going to show you here are the base 12 versions of the series of triangles where we have the square root of 1 for the hypotenuse, then square root of 2, square root of 3, square root of 4, and 5, and so on. So on this side, in base 12, square root of 0.3, 0.6, 0.9, 1, square root of 0.9, 1.6, 2.3, 3, etc. So on base 10, that would be 0.25. This is basically a quarter, and then this is 3/4. So 3/4 and a quarter gives us 1, a half, 1 1/2 gives us 2. So this would be 1.5 in base 10. And so on. Okay, so I'm going to show you something really interesting. We're going to use the example of the square root of 5 hypotenuse triangle. Okay, so here's that same triangle, and what we're going to do is just basically double the length of the bottom here to find out what it is when we do that. What's the answer to that sort of geometric process? So we're going to take the length of 3.75 and multiply it by 2, which is the same as the square root of 4. So 4 times 3.75 gives us an answer square root of 15. So then we're going to do the same thing exactly in base 12, so same thing. Square root of 1.3 is that length. Square root of 3.9 times 2, which is square root of 4. So square root of 4 times square root of 3.9. So 4 times 3.9. 4 times 9 in base 12 is 3 dozen. We would say 36, but it's 3 dozen, so we put a 0, carry the 3. 4 times 3 is a dozen. It looks like that. Add 3, so you get 1, 3, 1 for the decimal point. So the answer is 1 do 3. It's not 13, but 1 do 3. So here you have 1.3 and 1 do 3. So we've got an exponential growth there. We just had to move the decimal place, and we've got the answer to this very simple growth pattern. So that's built in to the triangle with these proportions. So that's another example of something coming into focus, an exponential growth that we don't really see in base 10. So in the next videos to come, we're going to look at something even more of a big deal with regard to base 12, and that's the base 12 version of pi. And no, it's not what you think. That's what you got to look forward to if you keep